All 6 of these are going to deal with this particular region. So I'm interested in the region bounded by y equals x squared and y equals 3x. All right? So again, my goal is just get through 2 today and do the other 4 tomorrow. So we're going to first draw this picture. And so when I draw this picture, y equals x squared, that's my parabola. Y equals 3x, that's this line. This is going to cross at 3, 9. Is everybody okay? That's our region?
Yes.
Okay. I'll go ahead and erase this part. And so question 1. I am interested in taking this region and we're going to revolve it, or we're going to rotate it around the x-axis. So am I going to have a vertical rectangle or a horizontal rectangle? Your rectangle has to be perpendicular to your axis of rotation. So is my rectangle a vertical rectangle or a horizontal? Vertical. Are we okay? So we're going to draw our vertical rectangle, our representative rectangle. And everything we do hinges on spinning this around. All right, so let's see if I reflect this. This is going to do this part. Oops, that need to be dashed. And then I draw my representative. And when you are doing a solid revolution, drawing the whole object isn't a big deal. It is not what's important. The most important thing you do deals with the rectangle. And so what we're going to do is spin that rectangle. And honestly, drawing the rest of the stuff, unless you're really good, ends up confusing people. Right? Because all you really care about is that rectangle and that washer it creates. And just so we can, you don't need to do this, after we do a few of these, you don't need to draw this picture, and you probably don't need to draw the picture now. But I do. I'm going to draw this sitting over here. So I've got my 2 concentric circles. And I have my important rectangle. Everybody see that? And anytime you have a washer, you have to identify, because you're going to do big circle minus little circle. And since you're going to do big circle minus little circle, you have to identify what's your big radius, what's your little radius. So I'm going to draw them. Is everybody okay? From here to here is the big radius?
Yes.
Is everybody okay? From here to here is the little radius? How that translates in this picture is from here to here is the big radius, and from here to here is the little radius. Right? So revolving this around the x-axis, right? We're going to do big circle minus little circle. So I want pi big R squared minus pi little r squared. Your job right now is telling me, okay, what's the big radius? Okay, everybody okay? Big radius is how big the blue rectangle is. And so it's top function minus bottom function. What's the top function?
3x.
What's the bottom function? 0. So are we okay that our big radius is going to be 3x minus 0? Okay, now let's look at our little radius. How big is the little radius? What's the top of it? How tall is it? X squared minus 0. Does everybody see the little radius is going to be x squared minus 0? And so this is going to give us x squared minus 0 squared pi. Did everybody see the big circle minus little circle? All right, now let's set up our integral. Now we go back to that original rectangle. Where are we stacking that original rectangle from? Is it x values or y values?
0 to 3. 0 to 3.
Does everybody see my original rectangle? That original rectangle is going to go from 0 to 3. Oh, I forgot to put the dx. So this is 0 to 3. And if you were to simplify this, you'd factor that pi out. And so this would be pi times the integral from 0 to 3 of 3x squared minus x squared squared dx. How's this? We got 5 more, and I know it's going to get incredibly repetitive, but it's the only way I know how to do it. Are we okay? Is everybody ready for, this is the first one? All right, so now let's look at the second one. So in your notes, you've got this written down. I need this space, so I'm going to erase this part. For problem 2, we're going to revolve this around y equals negative 2. Same region. But now we're going to revolve this around this line. All right. Vertical or horizontal rectangle? Vertical, because it's got to be perpendicular to whatever your axis of rotation is. And I should do a better job drawing that. And if I'm going to do the reflection of this part goes over here, this is going to go down. This is going to do this. But honestly, none of that really matters. The most important thing that you can draw is the reflection of your rectangle. And now, when I draw this, everybody see your washer? And so I'm going to set this up the same way I set the other one up. My big radius and my little radius. So the big radius, and your radius has to go from the axis of rotation. So you go from the axis of rotation all the way to the far end of the rectangle. And you have your axis of rotation all the way, axis of rotation to the closest end of the rectangle. Can everybody see the big radius and the little radius? Okay. Just curious, do you see how everything hinges on that little rectangle we drew? Mm-hmm. Everything hinges on that rectangle, right? Without the rectangle, you can't do the problem, or at least I've never figured out a way to teach it that way, right? So let's see what we know. So let's do pi big R squared minus pi little r squared. So, what's your big radius? Look at what you have in blue, right? Do top minus bottom. What's your blue radius? What? Oh.
Negative 2.
Minus negative 2. Does everybody see that? Top minus bottom, 3x minus negative 2. So my big radius is going to be 3x minus negative 2 squared minus, and I'll do pi. What's your little radius?
X squared minus negative 2.
X squared minus negative 2 squared. Is everybody okay with that? Now let's set up our integral. That just gives me one of these. Put a little dx. Where do we stack our rectangle?
0 to 3.
Now we see our rectangle is going to go from 0 to 3. I mean, has that rectangle changed from the last problem? No, so it's still going to go from 0 to 3. What it creates has changed, right? I mean, do y'all understand that this whole shape is generated by that one rectangle? Like, yeah, we're giving it some instructions about where to spin, but everything is generated from that one rectangle. And since that one rectangle hasn't changed, our limits are the same. Now, if this was a question on the AP exam, this is not how they would give it to you. This is not would be your answer. They would factor the pi's out. Like what they would have is this is pi times the integral from 0 to 3 of 3x plus 2 squared minus x squared plus 2 squared dx. And actually, if you look at your textbook, or any textbook or anybody else online, they don't put the pi's with it. They sort of factor the pi out. I'm not a huge fan of that. And the reason I'm not a huge fan is I really want you to understand it's big circle minus little circle. And when you look at this, I think it's easier to see, oh, it's big circle minus little circle. When you look at this, maybe you see big circle minus little circle, but I'm not sure.